Hello everyone, myself Shraddha Jadhav from India. I am currently working as a senior green building analyst in Eco4 Services Limited, a Tata enterprise. I have pursued my masters in environmental architecture from BNCA College, Pune University. Today I will be presenting my research on post-occupancy evaluation of user satisfaction and thermal comfort in a green office building. The following research consists of 8 chapters. First being introduction, second methodology, third, fourth and fifth will be the analysis of survey results and field measurements for user satisfaction, thermal comfort and user building relationship. The sixth and the seventh will be validation of the field measurements on CBE thermal comfort tool. The eighth will be discussion and conclusion. Introduction overview. India ranks third in US Green Building Council's annual ranking of top 10 countries for lead in energy and environmental design certified buildings. The country has around 24.81 million gross square meters certified space and around 899 projects in the lead participating in lead across the country. According to World Green Building Trends Smart Report 2018 by Dodge Data Analytics, it is seen that there will be a steep growth in green activity in the next coming 3 years, which will be in India, which will be driven by environmental regulations and drive for healthier buildings. The major challenges faced due to emerging Indian market is a lack of public awareness on feedback mechanism and green professionals who can create a framework for post-occupancy evaluation. Coming to the introduction, post-occupancy evaluation. Post-occupancy evaluation is a process of systematically evaluating the performance of building after they have been built and occupied for at least 1 year. It is used to gauge fitness for the purpose and how a building is performing after construction from occupants' perspective. So, there are 3 levels of post-occupancy evaluation. One is indicative level, which is done in 1 week, and the time required is only 1 week, and it can be done to a quick walkthrough. Also, it can be done to just highlight the occupancy issues. The second is the investigative level. The time required is 1 to 3 months depending upon the level of assessment. It can be done through qualitative and quantitative based approach. The third is the diagnostic level. The time required is 2 years and it aims at establishing a data in order to prevent uncovered deficiencies in design and operation of future buildings. The investigative level was followed for this research. The time taken was around 3 months and and qualitative and quantitative based approach was followed. Coming to project case study. The project case study is an IT campus located in Pune city, which is 150 kilometers from Mumbai in India. The IT campus is located far away from the main highway at an extreme end. It has north hills on the north and the northeast side and open area on the south side. The complex is divided into the following areas: development block, training center, ERC guest house, cafeteria, clubhouse and amphitheater. Post-occupancy evaluation was done for the development block building only. The building analyzed is a LEED India EBOM Platinum rated office building, and it consists of 14 floors and has workstations and service areas. All the floors are typical, only breakout spaces on each floor are different. Alternative floors are different. Coming to methodology, tools for measurement and evaluation. The tools for measurement were digital thermometer tool, which was used to measure temperature, wind speed and daylight values on site. The global thermometer tool was used to measure the mean radiant temperature on site. Tool for evaluation. CBE thermal comfort tool was used to evaluate the PMV and PPD levels. SPSS analytics software was used to analyze the qualitative parameters. PMV range scale was used to understand the PMV in that space. And vertical temperature difference, operative temperature and percentage of dissatisfied due to local discomfort was followed from ASHRAE 55 2010. Coming to sampling techniques and detail. Sampling techniques was done that there were some restrictive issues in the building since it was an IT building. So only the building was divided into 3 levels, that is lower level, intermediate level and higher level. From the lower level, 2nd floor was selected. From the intermediate level, 6th floor was selected, and from the higher level, 11th floor was selected. The floor plate was typical on all the floors, only the breakout spaces were different. So each floor plate was divided using stratified sampling based on orientation. So it was divided into ODC1, ODC2, ODC3 and ODC4. These random samples were selected from this ODC, which was based on location, which was near to the window between the desk and near to the dead external wall. Sampling details. Survey questionnaires were distributed amongst these random samples in each ODC. Mean radiant temperature of these samples was measured for two timings, that is in the morning and the afternoon, at head and ankle level. Daylight levels were measured with the help of digital lux meter in these ODCs. Research instruments and questionnaire survey. As mentioned earlier, research instruments were a digital tool meter, the survey questionnaires, and the observational survey. The survey questionnaire consisted of close-ended multiple questions limited to only one answer. In total, 100 samples were selected from all the three floors for analysis. Analysis of user building relationship. So, as you see in the chart, this pie chart tells about the space usage by occupants for breaks. So 30% of the occupants went on the breakout space on the floor level itself, 20% went on the landscape areas, 40% went to the cafeteria, and 10% went outside the building. So if the building breakout space in the building were designed in a better way with integrating with nature, then there was a probability that 50% of the occupants would have gone only in the building itself and would have avoided going outside the building. So the design pattern, the usage pattern helps us to understand how breakout spaces should be designed so that they have more integrated with nature, as these spaces enhance the health and well-being and have a effect on the productivity of the occupants. Coming to user satisfaction, the survey questionnaire which was prepared has had a section of user satisfaction parameters related to user satisfaction. The questions were asked on these parameters. So the first question was, how would you rate the daylight level in your workspace? The first parameter was daylight, which was considered over here. So 80% of the occupants said that the daylight levels are satisfying, whereas 20% said they are dissatisfied with the daylight levels. So when the daylight levels were measured, it was seen that in the exterior areas near the exterior glazing on the north side, the daylight levels were more than 600, whereas in the interior core areas, the daylight level was within 100 to 200 levels. So daylight levels majorly depend upon the building orientation and the window configuration. So as seen in the floor, in the interior core areas get less daylight levels because they have no exterior facade close by to that area, and the building configuration or the building planning is done in such a way that only one side of the building gets more daylight levels. However, the occupants are satisfied with the daylight conditions, and the building could justify the requirements of daylight levels in the workspace. So the daylight levels are well in as per the requirement. Coming to the next question, that is artificial lighting around your workspace. 80% of the people were satisfied with the artificial lighting in their workspace, but few were dissatisfied because of no user control on the artificial lighting in their space. The third is how will you rate the overall interior design of your workspace? So around 40% of the people were satisfied, whereas 40 to 50% of the people were dissatisfied with the interior design. The reason being the layout of the building, the interior planning was a cubicle type pattern, and that created a physical barrier, thereby obstructing easy communication with colleagues. The fourth is how will you rate the visual connectivity from inside to outside? So around 40% of the users were satisfied, whereas 40 to 50% of the users were dissatisfied with the visual connectivity. The reason being most of the users were seated with their back towards the exterior facade, and hence they did not have any connection with the outside views. Coming to correlation using user satisfaction. So the SPSS analytic tools was used to correlate the parameters with the objective, that is overall workspace satisfaction. It is seen that artificial lighting and interior design has highest correlation, following by daylight, quality, thermal comfort, and visual connectivity. So in this study, it is found that even if the parameters of daylight are fulfilled, due to inappropriate interior planning and design, and the rate of dissatisfaction has increased. So only 60% of the people were satisfied with their overall workspace in the building. Coming to user satisfaction of thermal comfort. The user satisfaction, the first question asked in user satisfaction survey for thermal comfort was, please rate your satisfaction with temperature conditions of your workspace. It is seen that on different floors, around more than 70% of the people are satisfied with the temperature conditions. Second question asked was, if you are dissatisfied with the temperature conditions in your workspace, what could be the reason for it? So on the second floor, 28% said it is slightly warm, whereas 22% said it is slightly cold. On the sixth floor, 30% said it is slightly warm, and around 17% said it is slightly cold. On the 11th floor, it is 30%, 13% said it is slightly warm, and around 46% said it is slightly cold. Coming to the last question, if you feel discomfort, what is the most relevant type of discomfort in your workspace? Around 60% of the people feel that the lack of fresh air is the most relevant type of discomfort, followed by others. So these results were then compared with the field measurements which were taken in the next section. So when the correlation was done for thermal comfort and overall workspace satisfaction, it also had a strong relationship. So this the right side, it is shown that how different parameters, and what in the descending order, how parameters are correlated with the objective, that is workspace satisfaction, and these should be given importance during planning and designing. So field measurements were taken for the samples in the morning and the afternoon. The ambient temperature and relative humidity on each floor was measured during those both the times. Once the mean radiant temperature was achieved or measured, operative temperature was derived with the formula. It is as given below. Then these operative temperature was inputted in the CB thermal comfort tool. The airspeed, relative humidity, metabolic rate and clothing was done as per ASHRAE 55-2010, depending upon the activity in that area. After inputting this, we could achieve the PMV and the PPD of that area. So as you see, so coming to the overall thermal comfort findings, on the second floor, it is found that the questionnaire survey said that 28% feel warm and 22% feel cold. On the sixth floor, the survey questionnaire results said that 30% feel warm, whereas on the 11th floor, the survey questionnaire results show that 45% of the people feel cold. Whereas the PMV range on the CB thermal comfort tool said that the range of PMV was from minus 0.05 to minus 0.23 on the sixth floor, minus 0.19 to minus 0.5 floor on the 518 on the second floor, and minus 0.34 to minus 0.64 on the 11th floor. So there was a difference in the perceived thermal comfort and the actual thermal comfort on the second and the 11th floor. The average PPD on each floor is below 10%. So as you see, the PMV and PPD ranges on all the floors are within the acceptable limit, that is minus 0.5, except the 11th floor, and the PPD is also below 10%. So on an average, when the PPD was measured, it is coming below 10%. So it is found that there is difference in the perceived thermal comfort and actual thermal comfort conditions. As per CB thermal comfort tool, the average PPD of dissatisfied is 10% and PMV is between minus 0.61 to 0. So ASHRAE 55 2017 states that the acceptable range of PPD is below 10% and PMV is minus 0.5 to plus 0.5, as I mentioned earlier. So further, one of the reason of discomfort could be warm or cold flows as per ASHRAE table 5.2.4, that is PPD due to local discomfort. So further to this, the floor temperatures of that area could be measured and could be verified by this chart also. Coming to discussion. So from the above post-occupancy evaluation, it is found that 60% of the occupants are satisfied with the overall office space. I also went back and saw the survey which was taken during the LEED certification. So that survey did not have any qualitative and quantitative related questions, whereas there are only questions related to the maintenance and operations of the building. There was only one question related to thermal comfort and daylight. So the survey result did not have well-structured questions at that time. Whereas the survey questionnaire which was prepared during the post-occupancy evaluation had a separate section for user satisfaction and had a separate section for thermal comfort. So all the parameters were considered during the questionnaire survey. Also, the field measurement survey helped out to find out the exact reason for thermal comfort dissatisfaction. After doing the survey results and after comparing them with the field measurements, the major issues which need improvements in this building are the obstructive interior planning and designing, no user control for artificial lighting, draft or warm or cold floors, and lack of fresh air. So the conclusion here is the results show that even if the building is LEED India E-Bomb Platinum rated building, the building occupants are not satisfied in their workspace. The satisfaction level is less than 80%. So there are few suggestions which I would like to give to the facility team, management team, or to the green building consultant. The green building consultant should prepare a post-occupancy plan for facility management team to follow at operational stage. This survey must be conducted in every 6 months post the building has been fully occupied and operational for at least 1 year. The building facility management team must be trained to carry out these surveys. The rating system must include a building audit and post-occupancy for a period of at least 3 years to ensure that the building is operated and as per expected in the design stage. The building facility management team, with the help of green building consultant, must approach LEED ARC and implement live monitoring of all parameters. All the qualitative and quantitative results must be compared to arrive at a conclusive result. A database of these POE results must be shared with all stakeholders for future reference. This database must be cloud-based and accessible to relative stakeholders on permission for future buildings. So this database helps a developer or to other stakeholders to understand what parameters are important and what parameters must be considered for relatable future projects. I hope this research has helped everyone to understand how a post-occupancy evaluation is carried out and how which parameters should be considered while designing a building and how they play a role in the user satisfaction levels. So I just hope that we continue making and building holistic buildings in the future. Thank you.